Hey, good afternoon. Welcome back. Happy Wednesday. So first, we'll just say a couple of things about the test. The median on this test was a 76. The mean was a 75, about the same. The high grades were 195. I would not have gotten 100. I made a mistake on one of the problems. I think I would have had like a 97 or something. So that's not me. I'll say that 76 and 75 are lower than our medians for the previous classes. I don't have them written down, but our other two quests, the medians were something like, one of them was really high at a 90 and another one was like an 82-ish. So 76 is certainly less than these two numbers, but I've been talking to one of my colleagues who's taught 106 for many years here at GCC, and she says that the grades on this particular quest, the one on these exponent properties, are historically even lower than the 76 that we've got here. So the average in her class was right around the same number, and she was thrilled that it wasn't worse. She says typically it's lower. Exponent properties are just tough, and there's so many of them and so many different things that you might try when you're faced with a brand new complicated exponent problem. So you know, not as good as our previous quest, but I wasn't expecting them to be as good as those. That is all we'll say about the test. I think, was there homework due today or no? Like the second day of factoring, right? So I'll come around and check, but I'll take it next time. I know it's been a while since we assigned that homework. So I'll check it later on today. We'll go ahead and take a quick look at just one announcement. On your tables, thank you to Katrina for passing this out. Everybody have one of these? This is what's in your career skills toolbox. Does every table have one? Yep, thank you. So anybody else need one? Did this table get up here? Okay, thank you. So there are quite a few people here at GCC working on trying to help GCC students as they take the journey from education to career, not just job, but career. And I just saw this last week, this document, and I think it's great. It's a bunch of actual steps that you can take to head you towards the career or continue you on that journey. So, you know, this isn't something where you just like bang it out in 5 minutes. I mean, this is like something you take your time and you thoughtfully go through, you know, each of these rows, and you learn how to improve your resume and talk about interviewing, and you learn about different websites that will give you information about current jobs in this area and what average salaries are and how many job openings you can expect 2 years from now. So there's a lot of good resources here. Again, there are people here working on your behalf, and so I'm just trying to connect you to some of the work that they've done. So I'd encourage you to work through this. Any questions on this? Okay, I'm happy to email this to you if you want, just let me know. All right, so we will take our look at the calendar. We just had our quest. The previous two classes that were not covered on the quest was all about factoring trinomials, so we'll do some more of that today. Today we talk about solving quadratic equations. That's going to be a big topic for us over the next few days. I just want to highlight, today is April the 10th. Our next class is not until April 17th. It's a week away. This coming Friday is Professional Development Day here at GCC. We're open, but there are no day classes, okay? Monday is Patriots Day. There are no day classes on Monday. There are Monday evening classes, so if you have a Monday night class, you go to it this Monday. But we don't meet each other again until Wednesday next week, all right? Okay, so let's go ahead and jump in. I think we are here. So Melanie had asked if we could just take a look at this homework question. I'm guessing the question said factor this thing. Okay, so let's factor. All right, my first impression, having not looked at this formula, this problem in many months, I haven't thought about this since I typed the assignment, and that was back in January. So my first impression is, okay, I see a 2 up there. I know a lot of stuff about factoring when it's an x squared. I'm a little bit perturbed by the y squared, but to be honest, I'm going to ignore it for most of this problem. If you believe, let's do an easy one, x squared minus x minus 12. If you believe that this is equal to x minus 4 times x plus 3, and I'm hoping that we can all get to that kind of a thing. If I gave you the original problem, you can factor it this way. Then sticking a y and a y squared is equivalent to sticking a y and a y. And if that's not something you believe, then take this and FOIL it. Let's just do a couple of the terms here. First, what do we get? X squared, that's there, no problem. Outers, is 3 times x times y, right? 3xy. Inverse minus 4xy. So altogether, we're looking at 3xy and then minus 4xy. How many xy's do we have? We have negative 1 of them, right? Which is exactly the thing here in the middle. And then if we do the last, negative 12y squared. Yes, multiplying those together, negative 12y squared. So even though it might look a little more complicated, the y's don't bother me in the least. I just know I'm going to ignore them and then stick a y into both parentheses, here and here. Okay, so let me just do that. I'm just going to ignore the y's. I'm going to rewrite this without the y's. 15x squared minus 4x minus 4. Don't write the y's. And we'll put the y's back in at the end. So some kinds of factoring of problems that look like this are the easy product sum idea, and the other ones are the harder, funky factoring. Which one is this? This is funky. How do we know? That's right. It's not just 1x squared. In this case, it's 15x squared. If it's anything other than 1x squared, it's the funky factoring. So let's remind ourselves, it's been since Friday that we've looked at this funky factoring together. So step 1 was to pick up the 15, and where do we put it? Put it into the minus 4 at the end. So we just go x squared minus 4x, and then what do we do with the 15 and the 4? Add them? Multiply them. And we get 15 times negative 4, negative 60. Okay? Everybody see what we did? Pick up the 15, throw it into the end. X squared minus 4x minus 60 is supposed to be easier because now it's like Evan said, it's a 1x squared in the front. So now it's legitimate to do this product sum idea. Product of negative 60, sum of negative 4. And so we're just going to make a table until we find the right things, but we're just looking for two numbers that multiply to negative 60. Negative 10 and 6 jumps right to the answer. Let's take our time as we get to the answer. So what if we did something like 1? 1 times what? Negative 60, yes. 1 times negative 60. But if you add them, what do you get? Negative 59, which is not what I want. I want negative 4. So how about 2? 2 goes into negative 60 how many times? Negative 30. Just looking for numbers that multiply to negative 60. Add those, what do we get? We get negative 28. It's closer to negative 4, but still got a little ways to go. 3 goes into negative 60. Negative 20 times. Add these. We're at negative 17. You can see we're getting there. Right? The goal was negative 4. We are closing in. So we'll skip past 4, 5, and eventually get to the one that Evan had suggested. 6 goes in how many times? Negative 10. And if we add these guys up, 6 plus negative 10, what do we get? Negative 4, which is exactly the sum that we wanted. Right? Sum was supposed to be negative 4. So what that means is that this guy is equal to, so we're going to put x, and what numbers go in? 15 will come back, but right now we're just factoring the green, which has no 15. So what two numbers did we decide go in here? Yeah. So we decided over there that there was a 6 and there was a negative 10. Those are the two numbers we settled on at the bottom there in purple. I didn't follow my advice. What did I forget to put into the table? Yeah, it's plus signs all the way through. So just to be clear, that's a positive 6. That matters because that's a positive 6. Evan. You don't need to put the pluses. I'm just putting it so we know that there's something that's got to go there. If you're not sure, it's because you didn't put the plus sign, but no, you don't need to put it for the quest. Okay, so there we go, x plus 6, x minus 10. Let me copy that again down below. And now we'll take Melanie's suggestion, x plus 6, x minus 10. Now we got to pay the price. We had a 15x squared to start with. We took that 15 and moved it. Now we got to bring it back. So where do we put the 15? In front of the x. Done? In front of both x's, right? This is the second to last step for funky factoring. You bring that 15 back, put it in front of both x's in both parentheses. And then we take each thing in the parentheses separately and we divide by the greatest common factor. What's the biggest number that goes into 15 and 6? 3. What's the biggest number that goes into 15 and minus 10? 5. And if we just divide these guys separately, we will have our answer. 3 is going to go into 15 and 6. 3 goes into 15 5 times. It's very wrong to put a plus 6 there. That 3 is underneath the 6 as well. So what should it be? Plus 2. And then over here, 5 into 15 is 3 minus 5 into 10, 2. So we have factored 5x plus 2 times 3x minus 2. This is what we started with, 15x squared minus 4x minus 4. That is equal. You can FOIL it and check. But remember we did one little thing at the beginning. This problem was more complicated. We ignored the y's. So we just bring them back. Where do they go? Right at the end, right after these 2's. So our final answer is 5x plus 2y and 3x minus 2y. So that's it right there. It's a process. I don't think it's a hard process. It just had a lot of steps in it. But I think with practice, this process can become very fluid.
I have another question.
Evan.
Well, would we be able to do the problem if x is out of the equation?
Yeah, if you took the x's out of the equation, it's a good question. So 15 minus 4y minus 4y squared, that?
Yeah.
You would want to rearrange it. So for me, I always like the x squared term to be the first thing, and I always want it to be a positive number. It doesn't have to be, but for all the product sum stuff that I do, it's a positive x squared in the front. So so you would rearrange it. You'd want that 4y squared to be first, but it's negative, so I think you'd end up needing to take a negative out of all the terms. If you distribute that negative sign through, you'll see you get exactly what we started with. You can totally do this problem same way and then stick the x's back in at the end. Yeah, good question. So I might regret doing this, but we're going to show you real quick this wonderful website called Wolfram Alpha. Anybody been there before? I love it. All right, wolframalpha.com. So I'm going to type in exactly what the problem was that Melanie shared with us. It was 15x. Here's the power button. Is that caret? 15x squared minus 4xy minus 4y squared. Is that right? Okay, so you just type it in plain English, and let's see what Wolfram Alpha says. So this is a free website. So here's what they interpreted. They wanted us to, they think we want them to factor that guy. And so we'll scroll down just a tiny bit. Is that what we got? 3x minus 2y times 5x plus 2y. 3x minus 2y times 5x plus 2y. There's a pretty picture. There's more pretty pictures. So it doesn't show the steps. Now you can create a free, you don't have to pay money. You can create a free account. There are no steps for this problem, but there are steps for some problems. And then you can ask it to show you the steps, which is a nice resource. In order to do that, you need to create a free account on this website. I have a free account, so I can log in and do that. There is a paid version, but you don't need to upgrade to that. I think you get like 3 free step-by-step solutions every day or something like that. Yeah. So Wolfram Alpha is a really nice resource. You can tell it lots of math problems, and it can answer lots of math problems. It's not trying to be Google, because Google just gives you search results based on popularity. This is not sending you anyplace else. Wolfram Alpha has access to a tremendous amount of data, and then it has its own kind of interpreter. We type something in English, and it interpreted it, and then it's got its methods for looking into its database and then solving. And then it decides how to show you the material. So there's a lot of good stuff happening with this website. I'd encourage you to. Okay, so let's start the new stuff here on page 38. We'll go here to the middle of page 38, and we will begin somewhere. Can we start with Sam? We're starting right here in the middle.
Today's class is to work with quadratic equations. Y equals ax squared. For a,
Okay, so first let's look at a quick example of an easy quadratic equation. Y equals x squared minus x minus 12. That is a living, breathing quadratic equation. So anytime you have a power up there of 2, we are bringing in this new word, quadratic. Quadratic. Which is kind of weird, actually, because quad normally means what? Normally means 4. I know it's strange. I think it has to do with square. I mean, I think it does. That, you know, square has 4 sides, and yeah. But that is the word we use when the power is 2. How much are A, B, and C in this equation we just made up? A is 1, which is your favorite A in the world, right? A is the number in front of x squared right here. B is the number in front of x, -1. C is the number sitting by its lonesome, is -12. So if A is 1, you get very happy, because then the product sum idea is valid. And then there was this restriction here. It said, how come A can't be 0? If A is 0, what's going to happen to this term? It'll disappear. It won't be there at all. And so if that's not there, and it's not called quadratic, it's if I asked you to graph y equals bx plus c. Yeah. If this term isn't here, then bx plus c, oopsie, bx plus c is something that for us was an mx plus b. It's just different letters. But if you don't have the x squared term, then it's just a line. And we've talked quite a bit about lines, but now we're going to expand to some curvy shape. So yeah, so quadratic just means you'll see an x squared in the problem. All right, let's move on to this next example. It says the table and the graph are for the quadratic equation y equals 2x squared minus 5. 2x squared minus 5. So let's first look at the table, because I think the table is used to make the picture. So let's try plugging in. Let's plug in x equals 2. If I plug x equals 2 in here, y is equal to 2 times 2 squared minus 5. Just picking x equals 2. Y equals, remember the exponent has to come first. So 2 squared is 4, and then we subtract 5. Which one do we do first now? Multiply, right? We're doing the order of operations. So that's 8 minus 5, which is 3. So when we plug in x equals 2, we get out y equals 3. Yeah? This means we have a point. Which one goes first, x or y? X. What x did we plug in? 2. What y did we get out? 3. Point 2 comma 3 is right here in this row. And so with a little bit more time, you guys could fill this table in, right? It could be completely blank, and you could just fill it in on your own by doing calculations like we did there in blue. Yeah? And then if you have a point, you can plot it. And so maybe on the graph, find the point 2 comma 3. Put a dot on the point 2, 3. It's on that curve. 2 comma 3 is this guy right here. Yeah? 2, comma 3. And so if you plot a lot of points like the ones in the table, you will connect them and get some kind of a curve like I'm showing you here. Now the curve was obviously created with a computer, so the computer plotted way more points than we have in the table, but it's very easy for a computer to do that. So if you plot all those points, you get that curvy thing. And we'll talk quite a bit about why it's curvy and what its properties are, and we'll give names to things related to that curve. Anybody know the name of that curve? Parabola. We'll spend time talking about parabolas. We've talked a ton about graphing lines. Parabola is the other thing that we're going to focus on graphing this semester. We'll get there soon enough. But for right now, we'll just say it's that curvy thing, and it just came from plotting a lot of points, like the ones in the table. All right, let's see if we can answer some of the questions here. First one says, what is the y-intercept? First place I want you to look is the graph. Where will we look in the graph to find the y-intercept? This is on the y-axis. On the y-axis is this point down here. If you had to ballpark, looks like about -5. It's hard to know because we don't have, the axes aren't super clear, but it looks like -5. Yeah, so we'll look over there to confirm. But it looks like -5. Which one is -5, the x or the y? It's the y. And how much is the x if you're, yeah, so that looks like it's the y-intercept at 0, -5. But if it happens that you have the equation, that's the equation that dictates everything about this curve. You can just plug in, you can say, wait a minute, if it's the y-intercept, then I know x. What is x? It's definitely 0. Without having the picture in front of you, if it's the y-intercept, x is 0. So plug x equals 0 right there. The whole part drops out, right? If x is 0, this part becomes nothing. 2 times nothing. So the entire thing becomes -5. Oh, super. We were right. It's at 0, -5 without referring to the graph. And if you happen to have a table and it happens to have 0 as one of the entries in it, then you got really lucky and you can just read it from the table. And right there we see, again, 0, -5. So the y-intercept is either -5 or, if you prefer to write it as a point, 0, -5. Any questions on that? Okay, let's look at part B. How many points have a y value of 13? How many points? Yeah. So one thing you can do is just look in the table. How many points have a y value of 13? So just looking in this column of the table, you're looking for the number 13. How many times do you see it? Twice. And so that's fine, and the answer is 2. The problem is that, like for example, if it said 12 instead of 13, how many times does 12 appear in this table? 0 times, but that just means we didn't happen to hit the 12. It doesn't mean it's not there in the picture. So maybe a little bit more accurate than looking in the table is to look at the picture. I'm looking for a y value to be 13. If I asked you to graph the line y equals 13, because there's no x in it, this is one of our special lines. If the line has just a y equals, it is either always vertical or always horizontal. With one arm, can you guys weigh in? Y equals 13. Is it vertical or is it horizontal? Move your body. Pick one of these things. An arm. Y equals 13. It's going way back. Y equals is always a horizontal thing. So y equals 13 is a horizontal line. Up at 13, the 13 is kind of almost off the page here, but I'll just put a 13 right there, ballparking it. And then I will draw a dotted line right up there, y equals 13. And now I'll look at my curve, and I'll say, okay, how many times does that dotted line hit the curve? Hits it twice. And both of those points are points where the y value is 13, because every point on the dotted line has the y equal to 13. And the nice thing is that if I had drawn my line at y equals 12, how many times does that line hit the curve? Also twice. Even if it's not twice that shows up in the table, we can see that, gosh, every one of these lines hits the curve twice, right? Is that true? Every line hits the curve twice? Yeah, there is one very special one way down there at the bottom, where how many times does that line hit Just once. That's a really unique case. Like move it up just a millimeter, and how many times will it hit? Twice. So they all hit twice, except for that really special one that just happens to be right there perfectly at the bottom when you guys take calculus in a few semesters. I'm just setting a bar for you guys. That's all I'm doing. Then you will talk about lines like this that just hit the curve, barely graze it, and then run away. Those lines start with a T. Anybody know what kind of line hits the curve just once and then runs away? Okay, you haven't taken calculus yet. Those are called, what's that? Excellent. Those are called tangent lines, and you'll spend a lot of time in your calculus class talking about those. Okay, great. So then I'm imagining all these purple lines that hit twice, 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 once. And then what happens if I slide down another millimeter from the bottom? 0. So it feels like most of the time it's 2, but just this rare spot where it's 1 and then nothing down below after that. Okay, so that's fine. And if we come over here and again focus on our line at 13, it happens that I plotted those points specially so we could answer this question right here. But you see the 2 points up there at negative 313 and 313, yeah? And those are just these 2 points here, first and last. So if I asked you to, okay, so then we can answer part B. Part B says how many points have a y value of 13? 2. So that's the answer to this. 2 points have a y value of 13. How many points have a y value of 12? 2 points. So it's just about all the time it's 2. But then down here we say write the coordinates of the points that have a y value of 13. And it happens that they're in the table, so we can just grab them from the table. So let's grab them from the table. The first point with a y value of 13 is negative 3 comma 13. And the other point, positive 313. Okay, so far so good. And we can see that from the picture too, right? 313 and negative 313. Just looking for places where the y coordinate is 13. Okay, now we're going to make a transition, but I'm hoping it's something that will trigger some memory for those of you who took 105 here. I'm going to now transition away from thinking about that graph, but towards thinking of solving an equation. 13 equals 2x squared minus 5. 2x squared minus 5 should look familiar. It's exactly the equation that we've been thinking about, or it's the expression we've been thinking about. Okay, but now I'm really going to try to focus on these 2 things highlighted in blue. What's the only difference? The y became 13, which is kind of interesting because that's exactly the problem that we answered here. Find all the points where the y is 13. So what I want to convince you of, or remind you of, if you took 105 here, is that solving the equation 13 equals 2x squared minus 5 is exactly the same problem as find all the points that have a y value of 13 for this graph right here. And so if I want to answer this question, 13 equals 2x squared minus 5, I'm looking for values of what letter? What are the answers to this kind of equation? Is x. There's no y in this equation, right? There's no y in the 13 equals equation. So the answer is going to be x equals. So looking at the previous line, we had 2 points where the y was 13. How much was the x? Yeah, one answer to this problem is x equals 3. Another answer is x equals negative 3. Those are the 2 solutions to 13 equals 2x squared minus 5. And we can check. Just do one of them. X equals 3. If I try to do 2x squared minus 5, and I'm deciding what value am I putting for x? 3. I'm just trying to check by plugging x equals 3 into my equation. What do I do first? 2 times 3 or 3 squared? 3 squared. Make sure you do that first. It's so tempting to do 2 times 3 is 6. 6 squared is 36. It's wrong. Got to do exponents first. So the 2 is just hanging out. 3 squared becomes 9 minus 5. 2 times 9 is 18. Minus 5 is 13. So if you did 105, and in particular, if you did 105 with Sandy, I am certain that you did a lot of problems just like that, where it said solve this ridiculously complicated equation, much more complicated than the 13 equals 2x squared minus 5. And by the way, here's the graph of a line that has an awful lot to do with this ridiculous equation. And it would be just a matter of, okay, they want me to draw in the purple line at 13, and they want me to find the point, and I can find the point by just coming straight down to the x-axis. Y is 13, find the point, come down to the x-axis. -3, +3. Does that look familiar to folks who had Sandy? Okay. Okay. All right, and as you can see, when you solve a quadratic equation, you can get more than one solution, which is very different from every line equation that we've solved. If you are intersecting two lines, how many answers are you going to get? Probably going to get one. If you just draw two random lines on the board, they will probably meet at exactly one place. What are the other possibilities? It could be parallel, not meet at all. We could be sneaky and make two lines that are exactly the same, and then they meet in every point. Is it possible to make them meet twice? Not possible. But if you have a curve, like the one that we've got here, and a line like the purple one, it is very possible to make them meet twice. And those are the two answers to this problem. Let's move on to the next page. Okay, where's our reader? Can we go to Michelle for 3? Okay, so here's the goal. The goal is to first make your equation equal to 0. So let's look at part A. X squared plus 16x equals -8x. You're going to make it one side equal to 0 by adding or subtracting the same thing to both sides. Most of the stuff is already on the left, so how about we move everything to the left? What do I do to move the -8x over? We add 8x, we add 8x, and then we're going to write our answer, except we're going to write it in a very sneaky way. Let's start with the easy part. How much is on the right-hand side? All right, 0. That's what we built. Standard form. This is the most important piece of it. 0. 0 is a good number in terms of having a quadratic equation. So here's the sneaky thing. I really want it to look like x squared first, then there's an x term in the middle, and then there's the constant sitting at the end. So what goes first is x squared. But if I were just copying the original, I would then put plus 16 plus 8x, which is not wrong, but it's not what we're calling standard form. Standard form implies it's in order. So the plus 8x for me is always going to be the thing in the middle. The x term is in the middle, and then the thing without any x's goes last. So that's our standard form. Okay, let's try part B. Here you have a choice. You can either move the 4x to the left or the x squared to the right. Personally, I always want my x squared to be positive, and it already is positive. But if you move the x squared over, what do you have to do to both sides? I have to subtract x squared, makes it negative. That's not as good to me. So I would move the 4x over. So let's move the 4x over by subtracting 4x from both sides. X squared minus 4x equals 0. Good. And then same idea here, move the 4 to the left-hand side, subtract it from both sides. 0. Okay. So let me, I'm going to make up a problem that we're going to do up here at the top. It's going to be this one here. X squared equals x plus 12. Let's try that. I think there's enough space up here for us to do this. See if you can squeeze this in. Okay, first step, identify that it is called a quadratic equation because it has an x squared. Now, that's what it is. Yeah, quadratic means x squared. We're going to be using that word every day for the next few weeks. It just means x squared. Yeah. Okay, once we know it's a quadratic equation, we do this thing. It's capital, must be important. We're going to set one side equal to 0. Where is most of the stuff? Most of the stuff is on the right. I say most because there's two things over there, x and 12, as opposed to one thing on the left. That's not so important to me. What's more important to me is what I said before. I really want that x squared to be a positive thing when all is said and done. So let's leave it on the left and bring over the other two terms. So how do I move the x over? Subtract x. How do we move the 12? Subtract 12. And now it's equal to 0. Great.
So is keeping x squared positive just kind of like a personal preference?
That is my personal preference, but it's because I like my product sum idea so much, and if it's not a positive x squared, then what I said about product and sum isn't true.
Oh, really?
You said it accurately earlier today. You said the reason product sum works is because what's in front of the x squared? 1. But if we make it negative x squared,
Okay.
it's negative 1.
Yes.
Product sum doesn't work.
Okay.
So yes, it's a personal preference, but I suspect a lot of people share this personal preference. Okay, so let's use this product sum idea. So product is this guy right here, and then the sum is this guy over here. And so I'm looking for two numbers to put next to my x's here so that we get a product of negative 12, sum of negative 1. Product of negative 12. Just name some numbers whose product is negative 12. 12 and negative 1, right? 2 and negative 6. 3 and 4, 1 plus, 1 minus. We need to make sure we pick the one that has a sum of negative 1. It's 4 and, yeah, it's 4 and 3 with a negative somewhere, right? We need them to add up to negative 1. So where do you want to put it? So plus 4 and negative 3.
Oh, whoops. I didn't see it.
Yeah. Yeah. Right. So negative 4 and positive 3. If that was too quick for some folks, because we didn't write down the chart. So if you really like the chart, then take your time in these problems and write the chart down. But I'm going to trust that with a little bit more time, everybody in this room can come up with that factored form. So here's the new thing. Also recognize I put equal 0. It's equal to 0 before, it's still equal to 0. Here's the new thing. Here's the reason why we care about 0. Ultimately, this is one thing multiplied by a second thing. Yes? One thing multiplied by a second thing. So this is some number and this is some number. I'm just going to write that. This is a number times a number. And apparently, when I multiply them, I get 0. There's something very restrictive about that condition. If I tell you I have a number in each of my hands and I multiply them and I get 0, what must be true? One of them must be 0, right? If you do 5 times 7, is it 0? No. 18 times 23? Nobody knows what it is, but it's not 0, right? But if you get 0, one of them had to be 0, right? 0 times 5, 2 times 0, 0 times 0, they could both be 0, but one of them has to be 0. And that's the idea. So what this means now, this is the new thing, is that either x minus 4 is 0 or x plus 3 is 0. That's what it means. One of those two things has to be 0. We just write them down separately. You guys are going to do this a lot. It's almost the answer. Yeah, the final answer is x equals. So if x minus 4 is 0, how much is x? Is it 4 or negative 4? It's 4. And you can do that by adding 4 to both sides. So here we get x equals 4. That's one of our answers. Subtract this 3, and we get x equals negative 3. That and that. Those are our two answers. Just going to do this down here while people are finishing copying the steps up above. Whoopsies. Okay, so while we're writing stuff down, I'm just going to ask Wolfram Alpha to solve the original equation, x squared equals x plus 12. So we're scrolling down. Let's see what it thinks. All right, I think we're good. Solve that. Huh. I drew something. All right, if everybody's got this, I'm going to make my Wolfram Alpha full screen. Everybody's got it? Okay. It drew something that looks quite familiar, actually. It drew something that looks like that curve we saw before. It is a parabola. Here it's a diagonal line instead of being just a horizontal line, but the idea is still there's these two red points where the two things meet each other. And those 2 points are the answer. So if I can come down here and I just put this guy right on that point or as close as I can, ballpark, how much is the x if you go straight down from this arrow? Looks like around -3. Right, we're just going straight down from that guy right there. And then I'm going to come over here and then ballpark straight down from here. It looks like about 4. And those are exactly the two answers we got, -3 and 4. And then Wolfram Alpha also plots our two numbers here, and it tells us the answers right there, -3 and 4. Okay, so that is that. Why don't we do one last one like this and then the group activity. So let's try number 6. We're going to solve 2x squared equals 4x. Remember, standard form means one side is equal to 0. Is it in standard form? No. So subtract to make one side equal to 0. But again, I like my x squared positive, so I'm going to bring the 4x to the left. Okay, it might be tempting to say, okay, so then either 2x squared is 0 or 4x is 0, right? Set the two pieces equal to 0. This is jumping the gun. You get to say that one thing is equal to 0 when you have done work to turn the original problem into multiplication. Some number times some other number. That's when you get to set each piece equal to 0. You don't get to do it, whatever. You don't get to do it. You don't get to do it here when it's subtraction. So instead, we need to turn it into multiplication. Did we seriously lose did we lose our floating toolbar? No, it's right there. Okay, let's come back and we'll try old school. Okay, so we need to turn it into multiplication. And the way we do that is to factor. Now, it could be the case that it's going to factor like that, except this one is different. Yeah, this one is a little bit unusual. Normally, there's some x squareds, then there's some x's, then there's a third number sitting there by itself, and there isn't one in this case, which actually means the factoring is even easier than this. What it means is that we can factor something out of both terms. What can you take out of 2 and 4? 2. I have x squared and I have x. You get to take out the smallest power of x you see, which is just a single x. Now, we have gotten very little practice with this. This is something that I owned on Friday. I said I didn't give very much practice at all with factoring out greatest common factors or greatest common divisors. So there is a stapled handout that everybody should have a copy of. Does everybody have one of these on their table? So that is my attempt to try to right the wrong. The first page is a matter of finding the greatest common factor, like 2x in this case. So lots of practice there. And then towards the bottom of the first page is where it actually asks you to factor out that thing like we're about to do here. And on the back, there's more practice, and then there's the answer key, okay? It's not going to be graded, but this is something that I should have put in the packet and talked about. So at some point, if we don't have time during group activity today, maybe next class during the group time, but at some point, I'd like you guys to work through all of these and ask me about any questions you have. If people have questions, we can talk about them together. Okay, but let's factor out. If you have 2x squared and you take 2x out, It's a single x that's left. If you have 4x, you take 2x out, so 2. Okay, and then we're going to put in red. What is the symbol between the x and the parentheses? Multiplication. That's important. Ben? I got it because I've done all the practice on that greatest common factor thing. Yeah, what you're really doing here. Serious? How is that possible? Okay, so here's what's happening. 2x squared divided by, and then minus 4x divided by. When we factor out, you are just dividing everything by whatever you pull out. So this guy right here is going to go underneath both of these. So let's put it underneath both. 2x goes there, 2x goes there. That's how we figure out what goes inside. What is this equal to when you divide? X. That's the first x in the parentheses. What is this equal to when you divide? 2, and then the negative sign still there. So that's the x, and that's the minus 2. Okay, so then I think we're ready to move on to the next step here. Now that we've got that important red multiplication sign, we are now looking at a number times another number, and it's equal to 0. What must be true about one of these numbers? 1 has to be 0. So either the first thing, which is 2x, is 0, or the other thing in the parentheses. And then we have 2 equations we solve. Divide both of these by 2. How much is 0 divided by 2? 0. That's an answer. It's a perfectly legitimate answer. If you omit that answer, you will lose points. If 0 is an answer, it's got to be listed. Add 2 to both sides here. X is 2. Divide both sides by 2. Okay, so let me say this, and then we'll have about 18 minutes for group thing. Solving quadratic equations, that's an example of it right there, is super important for us. We're going to be doing a lot of solving quadratic equations. If I pull this guy up, next class, so today is solving quadratics. Next class is graphing parabolas. Then we have 2 days on the quadratic formula. All of that is involving solving quadratic equations, then quadratic models and solving quadratic equations. So solving quadratic equations is a big topic for us. It's going to spend the next 4 or 5 classes doing it. So let's get some good habits right now. So I want you to do the group activity here. It says solve each of these problems, and there are a bunch on the next page. First put them in standard form, then factor, then set each factor equal to 0, and then solve the new simpler equations. And I give you a big hint, these first 4 are all easy, 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 because, yeah, you can see the 0 in each problem. And then, so that step is done for the first 4, and then the factoring is also done. It's already factored. You'll have work to do if you look at the next page. That is not factored. You'll have to do work there. But you guys on these first 4 problems get to start right there at number 3. It's already factored, so don't make it harder. All right, flags are on the table. Help each other out. There is an answer key that follows. Let's see how far we can get, and I'll check homework right now.